I can do that. Thank you.
Okay, there you go. You're on now.
Hello, everyone. This is Sadhana Alangar, your host from HL7. Our speakers today are Nate Malubay and Dustin Burson. At this time, I'm going to hand over the program to Nate and Dustin. Hi, Dustin.
Thank you, Sada. Hello, everyone. My name is Dustin Burson. I'm a software engineer at Microsoft, and today I'm going to be talking to you about remote patient monitoring and the Internet of Medical Things. Also presenting with me is my colleague, Nate. Nate, would you please introduce yourself?
Yeah, hi, everybody. I'm Nate Malubay. I'm also a software engineer here at Microsoft, part of the health, cloud, and data team. I work with Dustin.
Thank you. For today's session, we're going to go over a few things. First, we're going to define what the Internet of Medical Things is, IoMT for short. We're going to go over some key scenarios, some of the challenges you might encounter if you're going to implement your own IoMT setup, and how you get started. And then Nate's going to take over the presentation and go over a demo application that he's built, highlighting an end-to-end scenario. So first off, what is an IoMT? Well, IoMT is the Internet of Medical Things. You can think of it as a subset of IoT devices that specialize mainly in patient health data. So they have things like the patient identifier, or can be associated with patients themselves. And the devices run the gamut of many different shapes and sizes. A lot can be worn, so they'll be like your Apple Watch, your Fitbits, other wearable devices. There's also ambient sensors, so sensors that live in beds that detect the presence of the patient and can infer biometrics, or just sense the presence of a patient as they enter the room. And there's also a category of usables or injectables as well. So what are some key scenarios? What we're going to be focused on mainly in this presentation is patient monitoring, which is the use of sensors and patient-reported outcomes to monitor patients. So we have scenarios for remote care, telehealth, early intervention, and return to work. And so, like, a more concrete example in the patient monitoring space, specifically around telehealth, is imagine a patient that has diabetes and has a continuous glucose monitor. By using data from that device and streaming it to their physician and their care team, you can have more comprehensive care and outside of the traditional clinical setting. And when that care is available, the provider has up-to-date information to make the touch point with that patient that much more meaningful. There's also applications within research and a whole host of categories within smart hospitals for augmenting care teams and workflow efficiencies. In addition to the key scenarios, the space is growing rapidly. So 89% of hospitals had some kind of IoMT implementation in 2019. And it's estimated by the end of 2020, 40% of all IoT devices are expected to be used in the healthcare industry. And the market reach is expected to be $340 billion by the end of 2025. So what are some challenges of IoMT? Well, if you're going to build an IoMT solution, there's a couple of things that you may want to consider or you would need to consider. The first is dealing with high frequency data. So, and it's possible to have an IoMT setup where you're just ingesting single measurements or a couple data points per day. But a lot of the more interesting scenarios come once you're ingesting data quite frequently. So we're talking about data every minute or every second and sometimes sub-second. Another key thing you would want to account for when building for IoMT is low latency. So you want to get the data in the hands of the provider and care team as fast as possible. A lot of pre-existing solutions either have an offline process where they give the patient essentially a flight recorder where they read data for a period of time, day, week, month, and then the data is then the recording device is then returned to some kind of place for the data to then be ingested. And that process can take a long time. So the ideal scenario is to getting the data within the hands of the care team within, hours, minutes, or best case scenario, seconds. The other challenge that you need to account for is being able to associate that data and link it to the patient itself. You want it to be part of their record so it can be used effectively with their care team. Another thing that you need to account for is supporting a multitude of devices. And this is important for scalability. A lot of scenarios where one device may have a signal or a couple of signals that are important, but if you wanted to build a comprehensive plan, you really would want to support multiple devices, each supporting their own unique strengths. Another key component when building for IoMT is interoperability, and this is where FHIR comes into play. By making the data available across a multitude of systems to be used in the patient care. And a key piece of this is also privacy and security. Concerns around, here in the US, HIPAA, and then HGDPR, or GDPR outside of the US, and with recent regulations and stuff in California, it's becoming a US concern as well. And then there's also challenges around updating the data. As data is streaming in, if you have modifications or new data for the stream, and also around late arriving data. So we're going to dig into some of the specific challenges that you may encounter. And I just mentioned late arriving data as one. So a lot of times these devices have themselves either direct connection or data that arrives through a gateway device. But that device doesn't always have internet connectivity, or the device itself has not always been in range of the gateway. So you need to account for data that would arrive, maybe hours or days from when it was read. Similarly, you may have to deal with data that arrives out of order. So maybe when the device is syncing, it's syncing the most recent data and then backfilling to when it last synced. So in that scenario, you have to make sure that the data is properly aligned and sorted and arrives in the medical record appropriately. You also have challenges around duplicates. So in the transmission of data, if it was interrupted in the middle and it has to restart, you want to make sure that we don't duplicate any data. There's also challenges around linking data to the correct patient. Not a lot of these devices actually know the actual patient themselves. There's also a tension between latency and load. So as we're streaming this data in, you have this, you want to make it available as quickly as possible, but you also don't want to overload your FHIR server in this case. There's also some unique challenges around how each device represents data. Especially when you get into the consumer space, there's a lot of different ways that data can be represented, and you really want to be able to ingest them and use them in a common manner. And then lastly, there's a lot of challenges around managing the number of resources created. You can imagine if you're sampling data every second, you really don't want to be creating observations for every second of data that you ingest. That becomes a real challenge, especially when you go to read that data and reason over it, and even just present the data to someone. So that brings us to the IoMT FHIR connector for Azure. It's an open source product that we released back in November. Excited to talk about it with you here today. It can output to any R4 FHIR server and be used with a variety of inputs to allow you to ingest your Internet of Medical Things data and land it into FHIR. Some common inputs are utilizing Azure IoT Hub or IoT Central. It integrates seamlessly with those products. The Azure IoT products allow you to do your device security and management. And then the IoMT FHIR connector for Azure allows you to ingest that data, transform it into FHIR. and utilize it within your clinical workflow. We also support cloud-to-cloud scenarios. So if you already have an IoT solution for managing and securing your devices, you can easily export the data from that solution into the IoMT Fire Connector for Azure if you need to interoperate with it in the context of Fire. And last, we have direct device connection into the connector. This is typically used for some startup applications, or if you just want to kick the tires and play around with it. Though we would recommend for anything at scale, you would use an IoT management solution in front. So what is the IoMT Fire Connector for Azure? Well, at a high level, we take high frequency asymmetrical data and we land it in Fire. So we provide an endpoint that can process high frequency IoMT data. It processes payloads of mixed data types. And it does this by first normalizing the data into a common intermediate format. And then it groups the data by device, type, and time. And then it transforms the data into Fire observations. And then lastly, it'll persist it in the Fire service that you configure as the final resting place. So what are some of the key benefits? First is scalability. So with built on the cloud and using Azure, you can start very small, have your proof of concept application, test it out, and then scale to meet your demands as your usage and stuff increase. The other key benefit is interoperability. We built this to leverage Fire so that the data can be interoperated between various entities and used in different clinical workflows. And then cost and time savings. So by being built on Azure, you don't have to worry about the server maintenance, the infrastructure costs. You can just leverage the underlying services that host the service. And then underpinning it all is security and compliance. The product has been designed for HIPAA, high trust, and GDPR so that you can enforce those workflows and security and compliance standards right out of the gate. So how do you get started? First thing is you go to the GitHub and clone the repository. Then you would go and deploy an ARM template, which is Azure Resource Management template. And then you upload your configurations for your device and Fire mappings. In more detail, we have 3 ways for you to get started. The first is using the IoMT Fire Connector for Azure with what we call a managed identity. So when you deploy your service, it comes with an identity specifically for that service. And then if you use the managed service for the Azure API for Fire, you can use that managed identity to connect into your Fire service. This is probably the quickest and easiest way to get started. But if you want to use the IoMT Fire Connector for Azure and you have another Fire server, you can also connect to that using an OAuth workflow. You just need to set up the appropriate application registration in your identity provider for the IoMT Fire Connector and configure it. Requires a little extra setup. And then finally, we have a sandbox environment that you can get started with PowerShell scripts. It includes deploying an instance of IoT Central, which allows you to either connect your own IoT devices or use the simulated devices that come out of the box. That'll generate data once every couple minutes. And then with the configured IoMT Fire Connector and Azure API for Fire, you can see the data being transformed and landing in Fire, and it gives you a nice clean end-to-end pipeline to play with and iterate on. So next step, I'm going to go through some mappings and highlight exactly how these work. These are specific to the demonstration that Nate's going to be giving here in a few minutes. So here we're looking at a sample device data payload. And I'm going to highlight a few things. Specifically, for brevity, we're just going to focus on the heart rate measurement and then the date, time, and device ID. So you can see here I have those highlighted. The heart rate has a 76 value, and then we have the date time of the measurement and the device ID itself. In the template, we have one important piece, which is this type match expression. So this is what basically says, hey, this template matches this measurement. It's a JSON path expression, and if it evaluates to true, then the extraction then continues for this specific template. Here we're extracting the heart rate and assigning it a name of heart rate, which is a common semantic type that we can then use later in the FHIR mapping. And then we also require that both a device ID and a timestamp be present for the measurement that we're extracting. And then the normalized data that we use finally for the FHIR conversion outputs like this. So we have a common type, then we have the timestamp and device ID, and then the list of properties that are associated with the type. So one key thing to note is, even though the inbound payload is very specific to the device, you can have multiple devices that map to the same heart rate normalized data type. So when you do your FHIR conversion, you only have to do that once. And that brings me to the FHIR mapping. So once again, we have the normalized data, where here we have the heart rate. And then we have this simple template where we're matching on the type, in this case, heart rate. We're associating a link code with it. And then for this example, we're converting into a value quantity. So we're going to create an observation with value quantity. If you're going to be doing a high frequency data set where you're sampling very often, then you'd actually want to use the sample data type. Another key piece is this period interval. What this means is, of 0 means is we're creating a single instance for the observation. So every single heart rate measurement that matches this template is going to create a single observation. Another option is to set this to some hourly or daily period. So if you were using that in conjunction with the sample data type, basically every hour we're creating an observation for that data stream, and then it'll be a time series format using sample data with everything contained within that observation. So that's an easy way for you to collect data by either an hour or a daily view, and avoid load on your FHIR server. And then here's an example of a final observation. A lot of other fields like data identifiers and stuff are redacted for brevity, but here we have the link code, the effective period, and the final value quantity. So with that, we kind of briefly covered some IoMT scenarios, some of the challenges that you may face when implementing your own IoMT architecture, and covered how the Azure API for FHIR and the Azure IoMT FHIR connector can help you ingest data from these IoT devices and make them available in an interoperable fashion via FHIR. And I'm going to turn it over to Nate to kind of go over a sample application. Take it away, Nate.
Thanks, Dustin, and thanks everybody for attending. Let me get my screen shared here. So the demo I'm going to show today is an end-to-end pipeline using FHIR that was really easy to set up, and it's set up with security and compliance in mind. And although this particular demo uses Azure components and Microsoft technologies, you can actually build similar experiences using other platforms. So first, I'm going to take a minute to walk through some of the components of this demo. So on the right side of the screen, you're going to see a return to work application running on my iPhone. So this application has a questionnaire that it's going to go through and collect patient-reported outcomes or symptoms from the user. It also acts as a gateway for a biometric device where we can collect actual data from the patient. And then it will finally provide a recommendation as to whether or not the user can return to the office. Now, I do want to make clear that this is a demo application only. None of the data you're going to see is reflective of actual COVID-19 symptoms being reported. And the recommendation is just, it's just an experience. It's just a way to illustrate an experience that you could build using this pipeline. So next we have a wearable device. So this is a wearable device created by a company named BioVotion. This is an Avirion. And I'm actually wearing one of these devices on my upper arm right now. BioVotion provided us this device and along with an SDK, and it gave us a really easy way to stream data to mobile applications. This device is actually capable of collecting 17 different measurements, but for this demo, we're only going to focus on 4 types. Those types are body temperature, heart rate, respiration rate, and blood oxygen saturation. So the next part I want to call attention to is the IoMT Fire Connector for Azure and the Azure API for Fire. So we've deployed these in our Azure subscription, and we configured the IoMT Fire Connector for Azure similarly to the way Dustin outlined in the first half of the presentation. So while we click through the app, I'm going to be going into some detail about the inner workings of the IoMT Fire Connector for Azure. And also in the Azure subscription, we've deployed an instance of Azure API for Fire. This is where all the resources for this demo are persisted. And then finally, we're going to be going to a Power BI Fire Connector to create a report in Power BI and visualize the symptom data on the map. I'll really quickly go over and just briefly show it. So this map represents symptom severity data in each zip code in Seattle. And again, I want to reiterate that this is just simulated data. It doesn't represent any actual COVID-19 symptoms in Seattle. And for those of you who aren't familiar with Power BI, it's a Microsoft tool used to create reports and visualize data, and it can be connected to a number of different data sources. We recently actually released a Power BI Fire Connector, which makes it possible for Power BI to make queries to a Fire API, not just the Azure API for Fire, and then create reports using the Fire resources. Okay, so now for the demo. So as I progress through the application, I'm going to drill into each step. To start, we seeded the Azure API for Fire with 3 different resources. Actually, there's several patients resources, several device resources, and then a questionnaire resource that we render in the application. So when I tap the start button, what's going to happen is it's going to fetch the questionnaire from the Azure API for Fire and then display the first question. So I'm going to drill in a little bit into the question. I realize that this questionnaire is a little bit too small for you to see, but let me zoom in here. So first off, there's this questionnaire contains an array, a contained array with 2 value set resources. These represent answer choices that are referenced in the questions within the questionnaire. So this questionnaire also contains two items. The first item is a question that references the yes/no value set. And the other item in this questionnaire is a question that contains 7 sub-items that represent symptoms. Each sub-item also represents the severity value set. And as I click through the app, you'll start to kind of see where I'm going with this. So we rendered the first question. You can see that we display the text of the item. So in this case, in the past 14 days, have you been within 6 feet of a person with a lab confirmed case of COVID-19 for at least 5 minutes? And then we also render a UI control at the bottom of the screen on the iPhone where we reference the yes/no value set. So for this, I'm just going to go ahead and click no. And then it'll advance to the next question. So you can see the next question here. The way we render it is we have the text from the parent item, which is in the last 48 hours, how severe were the following symptoms? And then we show the text from the first child item, which is chills, shaking with chills. So I'm just going to really quickly, I'll click none for that, and we'll click through these questionnaires. And as you can see, as we progress, it just iterates through each child item, showing the text from the child item. So shortness of breath, wheezing, sore throat. I've been talking a lot. I'm going to do mild there. Loss of taste or smell, no. Muscle aches or headache, none. And then nausea or vomiting, none. Okay, and so now we end up with this summary, and when I click submit, what's going to happen is it's going to create a questionnaire response, and it's going to upload that to the Azure API for Fire. I'm actually, because of the time, I'm going to skip over the questionnaire response section, but we do have all the answers that I answered and also references to the patient. So the next step in this demo, you can see that the iPhone app is actually collecting biometric data. My heart rate is a little bit elevated. My temperature is okay. Oxygen saturation is good. And my respiration rate is probably high because I'm talking. So it's actually reading this data from the wearable device, and it's sending it to the mobile phone. Once it reaches the mobile phone, we don't actually do any data processing. We just send we serialize it to JSON and send it right to the IoMT Fire connector. So it's uploaded. And then we go through the normalization process first. And I'm going to step through now how the IoMT Fire connector for Azure transforms this arbitrary JSON payload to Fire, starting with that normalization process. So here is the payload that we actually sent. And Dustin mentioned this earlier about mixed payloads. So you can see there are 17 different measurements that we're collecting from the BioVotion device. And we actually only care about 4. We're going to take out the heart rate, the oxygen saturation, the respiration rate, and then the core temperature. So we also are going to extract from this payload the time the measurements were taken. So this is represented by the measurement date time, and then the device ID. So when you set up an IoT Fire connector for Azure, you have to create the 2 mapping files that Dustin talked about to transform your JSON payload into an observation resource. That first file is a device mapping file, or in this case, I named it the normalization mapping file. And it contains templates that are used to normalize the incoming JSON. So on the right is the snippet from the device mapping file that I created for this demo. And this is used to normalize an incoming heart rate measurement. So first, what we do is we check to see if the incoming JSON includes a heart rate measurement. And this JSON path expression does this by looking for signals underscore 2x underscore heart underscore rate in the JSON. And you can see that it exists. So we know that this template can be used to extract the device identifier and then the time that the measurement was taken. And then with this data, what we can do is we can create, and then also, of course, the measurement, and then we can create this normalized data. So the next step would be grouping, and grouping is really for high frequency data. If you have a lot of incoming data, you can group the data together into a single observation. Because we're not using this feature in the demo, I'm going to skip over this step and move on to the transform step. And this is where we transform normalized data into an observation. So I mentioned earlier that there are 2 mapping files that you need to create to enable the transformation process. The first was the device mapping file, and the other file that you have to create is the Fire mapping file. So at the bottom left of the screen, this is a snippet containing a template used to convert the normalized heart rate data to an observation. And the top left of the screen is the normalized data from the previous step. So we use the type name to actually determine if this Fire mapping template should be used to transform the normalized data. And so we've established, that the value type can be used to be included in the observation. So what I mean by that is we create the observation, and then we need to look at the value type to see what type of data this is going to be. And we can see that it's quantity, so we create a value type quantity. Then we find the value in the normalized data payload. So here we look for heart rate, that's the name of the value, and we copy that value over to the observation. Then we're going to copy the system, unit, and code from the Fire mapping template to the observation, and this allows the value to be coded properly. And then any codes in the template are copied to the observation. So here we only have 1 code, but you can add as many codes as you want. You might have the SNOMED code, you might have some other proprietary code to support your business case. The point is that when you add codes to the Fire mapping template, it's going to just copy them over to the observation resource. Then we copy the time from the normalized data. So this was taken from the original arbitrary JSON payload. It gets copied over to the observation resource and stored under effective period. And here the start and end date are just the same time because it's a single measurement. And the next thing we have to do is we have to create references to the patient resource and the device resource. And so that's done by first fetching a device resource. And so I want to call this out specifically. The device ID in this normalized payload is actually an identifier. It's not the Fire resource ID. So this means that it's going to do a search to try and find this device. And if it's not actually created in the Fire server, it's going to throw an exception. So once the device is found, we copy over the device ID and set the device reference in the observation. And then we also set the patient reference as the subject reference in the observation. And so this is something else I want to call out too. This IoMT Fire connector for Azure has been configured to look up the device and patient when data arrives. And this means that there's an expectation that this device resource has a patient reference in it. And that patient reference gets copied to the observation resource. If that patient reference isn't there, it will also throw an exception and the payload that you sent won't be processed. So now that the observation is created, we can persist that in the Fire server. So now we have all of our resources in the Fire server and we can move on to viewing it in the Power BI report. So for this particular report, what we do is we fetch the observation and patient resources, and then we shape the data. And what I mean by shape the data is we filter out data that we don't need. So observations and patient resources have a bunch of fields we're not going to use, so we take that all out. And then we merge the data together. So we take the zip code from the patient's address and then attach it to all of the individual observations. And this allows us to map those observations on the map. And then we normalize that data for the report. And that means simply that we have a function that scores each observation on a scale between 1 and 100, 100 being the most severe COVID symptoms. So let's go ahead and move over to the Power BI report. So you can see here we have this map. I'm going to zoom in on this section over here. I believe that my patient that I filled this out for lives in this area, their home address. So when I refresh this, we'll see if it populates that area. So it's fetching the patient, it's fetching the observation, and then it's merging them together. And you can see it's a little bit of a tinge of yellow. If we want to drill into that, we can move over here to this bar chart and we can find that zip code. So the zip code is 98116, or postal code. So you can see my heart rate is red, very high, probably because I'm doing this live demo. And it's very stressful. And then my respiration rate is high too. So the heart rate, the measurement was 120 beats per minute. The score, that's 100. That's an indication of possible COVID. And again, this is just demo content. These aren't actual, this isn't an actual algorithm that can actually diagnose anything. This is just for illustrative purposes. Respiration was 33. Body temperature, I'm in the green with 37.3. The questionnaire score. So we actually send up, we score the questionnaire on the device and send it through the connector and create an observation. It was 3, so that's great. And then my blood oxygen saturation, plenty of oxygen. So I'm not going to drill too deep into the Power BI connector. Oh, let's see if the app will look at that. So the app says that it's okay if I go back to work. I'm not going to go too deep in the Power BI connector. If you want to learn more about the Power BI Fire connector, I really encourage you to attend Michael Hansen's presentation. It's on Thursday at 3:30 p.m. Eastern. And also I encourage you to go to our GitHub repository, Microsoft/IoMT Fire. Deploy an IoMT connector and build something. We're really, really excited to see what you guys can build. Thank you very much. And I think we have about 5 minutes for questions. Can you see questions, Dustin?
I can. I'm going through a few right now. Hold on one sec. So this one's probably, do you want to take this one, Nate?
Sure.
What are the core communication technologies used for IoMT? Wi-Fi, Bluetooth, cellular?
You're asking what the core communication, so how do we actually connect to an IoMT connector?
I believe that's the question, yeah.
So yeah, so the IoMT connector, when we deploy it, it has an event hub endpoint. And so it's, you can use different protocols for that. You can use AMQP, you can use MQTT, you can use HTTPS. In this demo, we're using HTTPS. It's of course via Wi-Fi because we're sending data over my iPhone and it's connected to my home router. And then of course the device is connected using Bluetooth. And so there's all sorts of different communications going on here. We're collecting data from the device using Bluetooth, then we're sending it off via Wi-Fi using a REST endpoint that communicates with the event hub. I hope that answers the question.
Okay. Here's one. Could you state again the package that rendered the questionnaire on the phone?
The package that rendered the questionnaire on the phone, are you talking about the, like the library I used or the actual questionnaire?
It just says the package that rendered the phone. So maybe if you could talk to both.
Sure. So I can actually maybe go back to that slide here. So the questionnaire, we had built an app previously that displayed questionnaire resources, and I actually turned that into a library that we use internally. And so that library allows us to very quickly spin up a demo like this. And currently it supports choice, it supports decimal, so there's different question answer types that it can support. But for the most part, and we'd love to hear from the community, if you guys think that would be a useful tool to actually put out in open source, we would definitely consider that. And then as far as the questionnaire, there are some formatting considerations when we took the questionnaire. So I brought up the first question in the questionnaire. You'll see that it's an item, and then there's also a sub item here that's yes, no. And so we do this just for ease of rendering in the application.
Okay, I think probably the last one we have time for is how's data secured using this approach from both the wearable device and mobile?
So that's a great question. The data security, number one, so the Bluetooth connection is a secure Bluetooth connection from the device to the phone. Everything, all the communication is encrypted. No data is actually stored on the device or the phone. So that's another security feature. Then we use HTTPS to send it to an event hub. That's a secure connection. The event hub doesn't actually persist any data. And in fact, the IoMT connector doesn't persist any data. And the only time data gets persisted is once it reaches the Azure API for Fire or any Fire server. So all along the process, all of the data is encrypted, and then the only place that it's persisted is in the Azure API for Fire, which is a secure data store.
Okay, great. I know there's quite a few other questions, but I think we're going to probably be answering them, via text. And I think we also created a Zulip chat for this and other Microsoft presentations if you guys want to connect with us and ask more in-depth questions.
Yeah, reach out to us on the Zulip chat. I think you can get a hold of us via email too, so don't be afraid to reach out.
Great. Okay. Thanks,
right,
everyone.
guys.
Thank you so much, Nate and Dustin. Excellent presentation, wonderful demo. Enjoyed it. Thank you all so much for participating. And we'll see you soon in another session. Till we meet again. Bye, everyone. Bye, Dustin. Bye, Nate.
Bye. Thank you very much.
Bye-bye.